In March 1944, the systematic examination of captured enemy aircraft had become a critical function of the Luftwaffe's Technical Intelligence Service at Air Proving Ground Rechlin, the Reich's primary aircraft testing and evaluation center. What German engineers and pilots discovered would fundamentally alter their understanding of American industrial capacity and the future of the air war over Germany. The arrival of a captured P-51 Mustang at Rechlin on March 6, 1944, provided the technical staff with their most complete example of the aircraft that was rapidly changing the balance of air power over the Reich. The aircraft had been shot down 2 days earlier during the first American fighter escort mission to Berlin. Luftwaffe intelligence had maintained that single-engine fighters lacked the necessary range to escort bombers to Berlin, a one-way distance of approximately 560 miles from English bases. This assessment was based on earlier captured P-47 Thunderbolts and P-38 Lightnings, both of which demonstrated limited penetration into German airspace before being forced to turn back by fuel constraints. However, the events of March 4 and 6, 1944 shattered these assumptions. On March 4, P-51 Mustangs successfully escorted a bomber force to Berlin, engaged in combat, and returned to England. 2 days later, on March 6th, approximately 660 bombers attacked Berlin, escorted by over 150 P-51s, proving the Americans had decisively solved the escort fighter problem. General Major Adolph Galland, who encountered the P-51 formations, immediately recognized the implications. His combat reports noted that American fighters were operating at full combat capability over Berlin, engaging aggressively with no apparent fuel conservation behavior, indicating they had reserves and were not flying at the limits of their range. This contradicted everything Luftwaffe intelligence believed about American fighter capabilities. The technical examination at Rechlin focused first on determining how this range was achieved. The P-51B had an internal fuel capacity of 269 gallons, split between 2 wing tanks and an 85-gallon fuselage tank. German engineers calculated that with a cruising consumption of about 70 gallons per hour, the aircraft could fly for roughly 3.8 hours, yielding a maximum range of 1,140 miles. This was precisely enough for the Berlin round trip, but left no reserves for the prolonged dogfights that German pilots were observing, where fuel consumption exceeded 100 gallons per hour. The answer became apparent when staff examined the wing structure and found standardized hardpoints with fuel line connections, clearly designed for external drop tanks. German fighters had used drop tanks for years, but the mystery was the capacity and production rate of the American versions. Within 3 days, search teams recovered 2 relatively intact external tanks jettisoned northeast of Berlin. These captured drop tanks revolutionized the German understanding of American industrial methods. Capacity calculations indicated each cylindrical tank held approximately 108 U.S. gallons, providing an additional 216 gallons of fuel and increasing the P-51's total capacity to 485 gallons. With this fuel load, the Mustang could fly for about 6.7 hours at cruise settings, yielding a range exceeding 2,000 miles, more than sufficient for the Berlin mission with substantial combat reserves. However, what truly captured the immediate attention of German engineers was not the capacity, but the construction. The drop tanks were not made of metal. Scraping away the silver paint revealed multiple layers of heavy craft paper laminated and compressed together with a resinous adhesive. The paper was strong craft paper, the kind used for heavy-duty industrial packaging. The adhesive was a resorcinol formaldehyde resin, a thermosetting polymer that created bonds stronger than the paper itself when heat-cured. The entire process was sophisticated and purposeful, clearly standardized and designed for mass production. The implications were immediately clear to the technical staff at Rechlin. The Americans were manufacturing fuel tanks from non-strategic materials. Paper and wood-based resins did not require the increasingly scarce aluminum, steel, or other metals. Crucially, the manufacturing process required no specialized metalwork equipment, no skilled metalworkers, and could be performed in any paper mill or packaging factory with relatively simple modifications. With the United States producing approximately 12 million tons of paper annually before the war, converting even a small percentage of this capacity could yield over 100,000 tanks per month, far exceeding any plausible requirement for P-51 operations. The tanks, which appeared to have no serial numbers or manufacturing markings, were commodity items, mass-produced and completely expendable. This represented industrial efficiency and resource optimization on a scale that German planners found difficult to comprehend. The paper tanks were strictly single-use items. The resorcinol adhesive was slowly dissolved by prolonged contact with aviation gasoline, necessitating filling just before flight, but the single-use nature simplified logistics, eliminating the need for recovery, cleaning, inspection, or maintenance. They were expendable by design. The innovation had originated in Britain in 1943 to conserve strategic metals, with the Bauer-Scott Corporation developing the production process. American forces quickly adopted the design, with multiple manufacturers in both countries producing them for the USAF. The resource-driven British innovation was being exploited on a massive scale by American industrial capacity. The technical staff's systematic review of other captured American equipment showed a consistent pattern. American equipment was consistently better manufactured, more standardized, more reliable, and available in vastly greater quantities than German equivalents. The American approach prioritized producibility over technical perfection, designing components for mass production by semi-skilled workers and assembly line methods. German equipment, conversely, was often a technical masterpiece, hand-fitted by skilled craftsmen, which severely constrained production rates. The Germans built superior individual items, but the Americans built adequate items in overwhelming quantity, and in industrial warfare, quantity had proven decisive. P-51 production numbers were a stark illustration. Combined output across North American Aviation's two facilities reached an average of approximately 574 P-51s per month in 1944. At peak efficiency, a new Mustang was completed approximately every 2 hours. This production scale and efficiency exceeded anything Germany had achieved, as Messerschmitt and Focke-Wulf combined produced only about 600 fighters per month in early 1944. The resource disparity was equally vast. American aluminum production in 1944 was about 10 times Germany's peak annual production. The paper drop tanks were not made from metal because of metal scarcity. The United States had sufficient aluminum to make every tank in metal. Paper was chosen because it was cheaper, freed aluminum for other uses, and could be produced more quickly with less critical manufacturing equipment and unskilled labor. This was optimization, not desperation. The psychological impact of the paper drop tank became a symbol of American industrial capability. The message was clear: American fighters could escort bombers anywhere in Germany, rendering the previous defensive strategy of waiting for Allied fighters to turn back obsolete. General Galland emphasized that the P-51 was superior to German fighters above 20,000 feet, being faster than the Bf-109 and more maneuverable than the FW-190 at altitude. The consequence was a catastrophic rise in Luftwaffe fighter losses. By July 1944, single-engine fighter losses in the West alone reached an unsustainable 31.2% monthly attrition rate. Experienced pilots were being killed faster than they could be replaced, with German replacement pilots often having as little as 30 hours in type before assignment, a fraction of the flight time of American pilots. Galland's September 1944 report bluntly stated that the Luftwaffe could not win the air war, as Germany lacked the resources, fuel, aircraft, and trained pilots necessary to contest Allied air superiority. American industrial capacity was beyond Germany's ability to counter through combat operations. The paper drop tanks falling across the countryside reinforced to the German population that the Allies had resources to waste, while Germany scraped for every resource. German technical staff concluded that while Germany could technically manufacture similar paper tanks, its chemical and paper industries were already fully committed to other critical wartime requirements, and there was no operational need for extended-range tanks given that fuel shortages were already grounding much of the Luftwaffe. The irony was stark. The Americans solved the range problem with paper tanks, while German fighters were grounded by fuel scarcity. Germany was fighting a war of scarcity against an enemy for whom scarcity was not a constraint. The final comprehensive analysis in late January 1945 concluded that the P-51 Mustang with expendable paper drop tanks had rendered the German heartland indefensible against American daylight bombing. Germany lacked the capacity to match American fighter production, the fuel to sustain operations, and the trained pilots to replace losses. Post-war interrogations of German personnel frequently cited the arrival of long-range fighter escorts over Berlin in early spring 1944 as the decisive turning point. The paper drop tank itself became a case study in wartime industrial innovation. It was not a technically superior weapon, but a deliberately simplified design using non-critical materials. That simplicity carried a devastating message. The Allies had overwhelming industrial capacity and could optimize designs for mass production and efficiency, using paper because they had unlimited paper, resin, and fuel. They were fighting an enemy so wealthy in resources that substitution was a choice for efficiency, not a necessity imposed by shortage. The P-51, with its combination of range, performance, reliability, and producibility, made it the ideal escort fighter. Its effectiveness was a successful integration of the airframe, the powerful Merlin engine, the fuselage fuel tank, and the drop tanks that pushed its operational radius beyond 800 miles, all supported by the industrial capacity to produce them in quantity. The story of the engineers at Rechlin examining those paper cylinders is an enduring insight into how industrial capacity determines the outcome of modern conflicts. The paper drop tank represented a clear symbol of industrial capacity applied with strategic purpose and the decisive advantage of overwhelming production capability in modern warfare. The ability to escort bombers throughout their missions over Germany, made possible by fighters like the P-51 carrying drop tanks, was among the decisive elements in the ultimate defeat of Germany.